Hello everyone, I'm here with a new subject which comes under the fourth semester of Electronics and Communication, Microcontroller of 8051. Under that, I'm gonna discuss about the stepper motor interfacing which comes under the fifth module of stepper motor interfacing. In this video, I will be discussing about the stepper motor, how stepper motor works, and some parameters on stepper motor, interfacing stepper motor with 8051 microcontroller, and full drive, half drive mode, which comes. These are the drive modes where how the stepper motor takes place. Like in this section, we will see how to connect a stepper motor with Intel of 8051 microcontroller. Before discussing the interfacing techniques, we will see what are the stepper motor and how they work. What is stepper motor? Interfacing. Stepper motor are used to translate an electrical pulses into the mechanical movements in some disk drives. We'll be seeing the different types of drives in the microcontroller of 8051 in the stepper motor interfacing. The stepper motor interfacing has three different drives. These are nothing but disk drives. See, dot matrix printers and some other different places the stepper motors are used. The main advantages of using the stepper motor is a position controller, and the stepper motor generally have the permanent magnet staff which is like rotor, and it's surrounded by the stator, which we will be seeing the diagram. Right. See, this is a stepper motor. See, there are mainly three, where is an north and the south pole. See, which is the blue one, which is nothing but the rotor, and the stator here the upwards, and the bow, see the edge one we call as stators. These are the three cases we'll be seeing the stepper motor. We will see half wave and full drive in the stepper motor. This is an block diagram of the stepper motor. There are some parameters of the stepper motors. That step angle. The step angle is an angle in which the motor moves with one pulse applied as an input of the stator, and the parameter is used to determine the positioning of the stepper motor. The second one is the steps per revolution. These are the number of offset angles required for the complete revolution. For the form, we will use the formula for the stepper. For revolution is nothing but 360 degree, right? Motor is like, we'll take as an earth as an example with rotates 360 degree angle. So stepper motor is also like this, which has a north and the southern pole by the three discs. So we'll consider as an 360. It is an steps per revolution, which has a formula of 360 by step angle. We have been seen and discussed about the step angle in the above one. Again, the step per second. This is a third parameter. The parameter is used to measure a number of steps covered in each second. The seconds are very important in the stepper motor interfacing. So the parameter is used to measure the number of steps covered in each second is nothing but step per second, which is a third step of the parameter. And RPM is nothing but it expands as revolution per minute. RPM is an revolution per minute, which measures the frequency of rotation. By using parameter, we can measure the number of rotations in 1 minute. How many rotations has been take place in the stepper motor interfacing, we can calculate by using the PRM, but the number of rotations in 1 minute. The some parameters like the relation between RPM, see the RPM per revolution and steps per seconds is like below. There is a formula. See, the steps per second equals RPM into steps per revolution divided by 60. This is an method we'll be using for the calculation of the stepper motor interfacing and some of the parameters we have been seen before slides. The interfacing stepper motor with an 8051 microcontroller. How the interface takes place under 8051 microcontroller of the stepper motor interfacing. See, we are using the ports like P0, P1, P2, P3. There are totally 4 ports, right, in the 8051 microcontroller. For connecting the stepper motor it has been Harulen in 2003 used that the stepper motor it has been used. This is basically an high voltage, high current transistor array which ULN of 2023 has in 7 NPN translating pace, and it can be proved the high voltage output with a common cathode clamp diodes from switching and inductive loads. See, this is a circuit diagram of this stepper motor. See, let's see. Let me zoom in it. So, okay. See, the extal 1, the extal 2, the reset pin, and present ALN and enable all. The ports are like P0 to P7, P01, P02, like till to P7. Again the P0 it carries where it has been connected to the R2, R3, R4 and R5. Here which comes again the common, it is UL1. This is a connection of the circuit diagram of the stepper motor of interfacing which I have been seeing here. Okay. The unipolar stepper motor works on the 3 modes actually. They works on the 3 modes: wave drive mode, full drive mode and half drive mode. First we'll discuss one by one. By seeing the circuit diagram and the previous I have been shown the block diagram of the stepper motor of interfacing. By 2, how the following table shows a sequence of input states in the different winding. The windings takes place in the stepper motor. Let's discuss one by one. The wave drive mode. The wave drive mode, in this mode, one coil is energized at the time, so all 4 coils are energized. After another energized, the mode product less torque than the full stop drive is in the mode. See, let's consider like, see, there are will giving as A, B, C, D. First the sequence takes place like giving as 0, 1, 0, 0, 0, 0, 1 and 0, 0, 0, 0, 1, 0 and 0, which gives a sequentially. Like, see, the slantly which gives the 1 and the remaining all 0. This takes place in the wave. It is like the wave. We will get like 1, right? Which gives the wave. And the full drive mode. The full drive mode, this mode, the 2 coils are energized. Where the 2 coils will be energized. There is only the one which is be energized. Here it takes place as full, right? So it takes us 2 coils to energize at the same time. This mode provides the more torques and the power consumption is very high in the full drive. See, this is a tabular column of the full drive mode. The half drive mode is in the mode that 1, 2 or coils are energized alternately. At the first, the one coil is energized and the second coil energized. This is basically like combination of the wave. And the full drive mode, it increases the angular rotation of the motor. This is an tabular column of the full drive. Thank you guys.